Hey everybody, lesson 4.1, solving percent problems using equations. Before you begin, I just want to remind you that there are generally a lot of different ways to answer a question. This just represents one possible way. This is a method that I'd like for you to know, that you do need to know. It is definitely not the only way to answer these questions. Please take a moment to complete the warm-up. Hopefully this warm-up has got you thinking a little bit about percents. Just kind of taking a look here, we have some percent basics. To find the percent of a quantity, there's a basic equation or formula where we would multiply P times Q equaling R, where P is the percent in decimal form, Q is the original quantity, and R is the resulting quantity, that percent of the original quantity. So 4% of what number is 76? We can see that 4% would be our P. We would use 0.04 here. The mystery number would represent our Q, and the resulting quantity is 76. We would enter that into our equation. 0.04Q equals 76. Undo multiplication by using division. Simplify. And we find out that Q is equal to 1,900. We can always check our answer by testing what is 4% of 1,900. 0.04 times 1,900. Does that equal to 76? Hopefully that would be the case. Obviously there are other ways to answer this question, but today we are going to be using equations. Let's take a look at another one. What percent of 210 is 33 6/10? What percent, that's an unknown quantity, of the original quantity 210 equals 33.6. We're going to go ahead and enter that into our equation. P, the unknown percent, times 210, the original quantity, equals the result, 33.6. Undo multiplication using division. Simplify. We find out that P equals 0.16. If we want to answer this question with a percent, 0.16 represents 16%. Again, there are other ways to do this, but today we are going to be using equations. Percent discounts and markups. This is where things get a little tricky. A discount, if we have an item that is discounted X percent, then what we're really paying is 100 minus X percent. And if we're talking about a markup, that would be something like a tax or a tip. If an item is marked up or increased by X percent, what we're really paying is 100 plus X percent. In both of these cases, 100 would represent the entire quantity, the entire original amount. We subtract X percent if we are talking about a discount. We have to add X percent if we're talking about a tax, a tip, some sort of an increase. An example of this would be that a bicycle normally costs $425, but it is on sale for 20% off. What is the sale price without tax? So we can do this the long way. This would be where we would calculate the discount and subtract from the price. So I would have $425, and I would be subtracting the calculated 20% discount. The 20% discount comes out to be $85 or $340. Now we can see like terms here. We have 1 425 minus 0.2 425. So there's a shortcut way. The discount is 20%. That means that we're paying 80%. 100 minus 20 is 80%. So we calculate 80% of the original price, $425, and we come up with $340. There's also an example in the book that highlights this that you can take a look at as well. In our next example, we're talking about Chauncey. He wants to buy a pair of jeans costing $44.50. He knows he'll be charged a 4.5% tax to find the total cost. The long way for this markup would be to calculate the tax and add it to the price. For example, here's the price of the jeans plus 0.045, $44.50. This will give us the 4.5% sales tax. Calculate out the sales tax, add it on. In this case, the price comes out to be 46 0.5025. We know in our monetary system that these two extra decimal places would not be useful and would not be used, so we need to do some rounding here. Since it is a tax, meaning this is the amount of money that the store will take in, they're going to round that up automatically, even though rounding to the nearest would indicate 50 cents. In this monetary situation, we would round up to 51 cents. The short way, if the tax is 4.5%, what we're going to be doing is we're going to be paying 104.5%, the original 100%, the original quantity, plus the 4.5% sales tax. So we multiply 1.045 times 44.50, giving us the same result that we saw on the other method, 46.5025. Again, the amount of money that the store is going to take in will be rounded up to 46.51. There's an example 3 on page 183 that will also help you with this method. Let's take a look at what happens if we have a different unknown quantity, if the result is not what is unknown. If I use my 15% off coupon to buy a new Blu-ray player, the total I paid with no tax, because this is Montana maybe, was $127.50. How much was the original price? In this case, it's the original price that I don't know. But I do know that I'm paying 85% of the original, and that's $127.50. Right here I can see my percent is 85%. The original is unknown, and the result is $127.50. So I'm paying 85% of the original, and that's equal to $127.50. I'm going to undo my multiplication, dividing by 0.85, and come up with Q equals 150. Answer the question, $150 is the original price. Now, a lot of people will make a mistake on this. They'll find 15% of this value and add it back in. But if we find 15% of this value, that's a different 15% than 15% of the original to be taken off. So we have to be super duper duper careful when we set this up. This is an instance where using the equation is almost necessary in order to answer this question. So we do want to check our answer. Is 85% of $150 equal to $127.50? And it is. Let's take a look at another example. The Johnson family bought a new minivan, including the 7.5% sales tax. It was $37,635. What is the cost of the van without tax? So in this case, again, we're going to know the percentage and we're going to know the resulting quantity, but we're not going to know the original quantity, the cost of the van without tax. So using our shortcut, we know that we're paying 107.5% of the original, the 7.5% sales tax added into 100. So we're going to enter into the equation 107.5% or 1.075 times the original quantity equals the paid amount, $37,625. We undo multiplication using division. We're dividing by 1.075, and we find out that the original quantity is $35,000. That was before taxes, so it is lower. $35,000 will answer our question. Again, a common error here is to find 7.5% of this number and subtract. But since this number is different than this number, the 7.5% of this number is different than the 7.5% of this number. So we want to check just to make sure. If this is the original price and I'm paying a 7.5% sales tax, will that give me the total amount paid? And in this case, yes, it does. A challenge question. I want you to try this before you reveal the answer. The key is in the setup. Please press pause now. Go ahead and give it a shot. Press play when you are finished. Only the answer will be revealed, not the work. So you will be actually working through this on your own. We will discuss it in class.